I'd like to walk you through each of these questions on the quiz today, and for our first task we are supposed to find the equation for this table of values right here. We can see that our pattern is to multiply by 7. If we test out each one of these, we continue the pattern, multiply by 7, multiply by 7. That means this is an exponential function, so we can use our formula for exponential functions, which is f of x equals a times b to the x, where a is our y-intercept and b is our multiple. So we already have our multiple over there. We need to find our y-intercept. That means that we need to take our pattern back 2 steps so that we can get to our x value of 0. Well, we can do that by dividing by 7 to reverse this pattern. We'll take it back 2 steps by dividing by 7 twice. So if I divide 1029 divided by 7, that gives us 147. Then divide that by 7 again, and we get 21. So 149 and 21 for those two values. Or 147, excuse me, 147 right here. All right, so that gives me f of x equals, and I now have my y-intercept right here because my x value is 0, goes along with that. So we get 21 times our multiple, which is 7. We saw that at the beginning. So times 7 to the power of x. There we go. There is our first equation. Okay, this next one, going from step to step, we can see that we're dividing by 5, and that can be written as multiplying by 1/5. So I'm going to keep that multiplication, and we're going to consider this as multiplying by 1/5. We have our y-intercept this time, so we have all of the information we need. We just need to spot that the y-intercept happens to be in the middle of our table here. We can see that from the 0 right there that we have our y-intercept. So we get f of x equals 10, which is our y-intercept right there. And our pattern is multiplying by 1/5. So we get 10 times 1/5 to the power of x. And there's our second equation. For this third one, we're supposed to draw the graph of this function, -3 times 2 to the x. So using our knowledge from the previous one, we know that this is our y-intercept, and we have our multiple of 2. So I'm going to go ahead and graph my y-intercept at -3, and we're going to multiply by 2. So let me scroll down here real quick. So my y-intercept is at -3. And if I multiply by 2, that gets me at -6 for the next one, and -12 for our third value right there. If I go take it back the other direction, I'm going to divide by 2, which puts me at 1.5, -1.5, then -0.75. Then we're going to divide that by 2, and so forth until we get closer and closer to the x-axis. So our graph looks kind of like that right there. And we need to now spot our pattern for domain and range. So we can see that we go forever in this direction. I can continue to divide by 2 indefinitely. And I go forever in this direction because I can continue to multiply by 2 indefinitely. So our domain is all real numbers. We can write this with this symbol right here. You could write the words all real numbers, or you could write this way, -infinity is less than x is less than infinity. So our domain is all values of x, and we have that is our domain right there. Next is range. We want to know what are all the possible values for y. So taking a look, we can see very clearly that we're going down to -infinity, but we do not continue to go up. Over on this end, over here, where we continue to divide by 2, divide by 2, and we get closer and closer and closer to 0. So our top end right here never crosses over the y-axis, which is a y value, or the x-axis, which is a y value of 0. So writing our range, we go down to -infinity, and our top value is 0, and the y values stay in between those. So we get -infinity is less than y is less than 0. So again, we can see we go all the way down to -infinity, but when we're going up, we continue to divide by 2, and we never get into positive numbers. So 0 is our ceiling there. All right, let's move on to the next. We are to write an equation that models this situation. Bacterial culture starts with 10,000 bacteria and doubles every day. How many bacteria will be present after 7 days? So we're going to start off by writing our equation. Doubles means we multiply by 2, so that's an exponential equation. F of x equals a times b to the x. So we get f of x equals, and our starting value for a, the y-intercept, is that 10,000. So 10,000. B is our multiple. If we double, our multiple is 2, and our variable still is x. All right, after 7 days, so the x represents our days, so we're going to plug in a 7 there. So that gives us f of 7 equals 10,000 times 2 to the power of 7. So we're going to do that calculation here, 10,000 times by, and in parentheses we're going to put 2 to the power of 7. So that gives us a total of 1,280,000. So the total number of bacteria is 1,280,000 bacteria. All right, moving on. We're going to solve this equation right here. So they have the same base. When we have the same base, we know that our exponents must be equal to each other. So we get 4x equals x plus 9. Solving this, we're going to subtract x. That'll give us 3x equals 9. Finish that out by dividing by 3, and we get x equals 3. Okay, you'll notice on the next one that we do not have the same base, and this cannot be written as a base of 9. So 9 is not going to work. 9 can be broken down to a base of 3, but this also cannot be written as a base of 3. So our old strategy right here is not going to work. We're going to have to do something different. So since we can't get the bases to be the same, we're going to separate this out into 2 separate equations, and we're going to graph it to solve it. So the first one is y equals 216 to the x, and the next one is y equals 9 to the x minus 2. Now the graphing application GeoGebra likes to use different names, so I'm going to use f of x equals 216 to the x, and we'll call this one g of x equals 9 to the x minus 2. And I have those graphed over here in GeoGebra. So we can see these 2 graphs, and it's really hard to tell if there's an intersection. Over here it would be our intersection if there is one. Now if we weren't sure how to click on this, we could actually go ahead and type in that command, intersect, like so, intersect, and it says intersect object and object. So we're going to type the names of those 2 objects, and this is why we call it f of x and g of x, because when I name them I can say f comma g for those intersections, hit enter. So if you weren't able to click and get that spot, which it's really hard to see, I can't tell visually that it's right there, you can get that command to do it. Okay, so going back to here, we can see we're looking for our x value. That's our variable, x and x. So our x value is -1, and we're going to have to round this, so we'll just round it to -1.4. Keep it to the 10th. All right, so we get right here x equals -1.4, and we were able to solve that. Moving on to the next one, we've got 27 and 9 here. Now these both can be broken down to have a base of 3. So I'm going to start by taking this 1/27th, and I'm going to break that 27 down into the base of 3. So that would be 1/3 to the 3rd power. So that's our fraction. That's not all we have though. We still need to keep this exponent over here, which is 4 minus x. Over on the other side, this 9 right there can be written as 3 squared. So that is not all we have right there. We also need this exponent. So that's being raised to the 2x minus 1. All right, moving on. I don't want this in the denominator, so I'm going to use negative exponents to make it so it's not written as a fraction. So that would be 3 to the -3rd power. Now my fraction has the base that I want, which is 3. And over here we get 4 minus x. Over on the other side, we have the base the way we want it already. So we get 3 squared, and that whole thing is going to be raised to the 2x minus 1. We need to use our power rule now. So we're going to take these exponents here and we're going to multiply them. Same on the other side, we're going to take those exponents and multiply them, and that will simplify our expression. So we get 3, and when we do negative 3 to the 4 minus x, that gives us negative 12 plus 3x. Over on the other side, we get 2 times 2x minus 1, so we get 3 to the now 4x minus 2. Our bases are the same. Wonderful. So that means our exponents must be equal to each other. So we get negative 12 plus 3x equals 4x minus 2. Let's solve this. So we'll subtract the 3x, subtract 3x, we get negative 12. This becomes 1x, or just x, minus 2. Add the 2 to both sides, and that will give us x equals negative 10. And we're finished with this one. Moving on to the next question. Again, we can't get the same base. So we're going to graph this in GeoGebra. I again have that graphed right here. And we can see from these two pictures that there is not going to be an intersection to these. So if we have a situation with two graphs that do not have an intersection, that means that there is no solution. So we're going to go back here, now that we've seen that, and we just write no solution. And the evidence that we have no solution is this graph. If we really wanted to check, we could type in the intersect command like we tried last time and do f comma g, and in that case it would say undefined, and it is undefined because there is no intersection to be found. So that one again has no solution. Moving on to the next one. We are to write a function. This is exponential growth and decay. So we know that this account earns 2.5% compounded annually. All right, so our original balance is $7,500. If we earn 2.5%, that gives us 100% plus the 2.5% for a total of 102.5%. That is going to be our multiple, so we're going to write that in decimal form. That would be 1.025. So there's our multiple. We have our starting value with the initial amount that we deposited here. So our equation is going to be f of x. Our a is that $7,500. Our b, the multiple, is going to be the 1.025. And our exponent is x. All right. And then we need to use the equation to calculate the balance after 10 years. So in that x, we're going to plug in a value of 10 and calculate it. All right, so that would give us f of x, or f of 10, sorry, equals 7,500 times 1.025 to the power of 10. Going over to our trusty calculator here, we get 7,500 times 1.025 to the power of 10 for a grand total of 9,600. We're going to round that to the nearest cent since we're using money, so that would be 63 cents. So $9,600 and 63 cents. Moving on to the next one. We see Utah's population grew 2%. So again, like last time, we start at 100%. If we grow 2%, that puts us at 102%. Written as a decimal, that's 1.02, so that will be our multiple. Our initial amount right here is our population currently, which was listed as 3.1 million. So our equation will be f of x equals 3.1, as in 3.1 million, times 1.02 to the power of x. All right, we're going to see what Utah's population is predicted to be in 20 years if that growth continues. So our x value is going to be 20. So we're going to plug that in here to our equation. All right, give us some space. So we get f of 20 equals 3.1 times 1.02 to the power of 20. Plugging that into our calculator, we get 3.1 times 1.02 to the power of 20. And we're going to round this to the nearest point, or the nearest tenth as far as millions go, so that would be 4.6 million people. Last, we have this question. In this instance, we earn 4% less each year. So this is exponential decay. If we're going 100% and we earn 4% less, that puts us at a total of 96% of the previous value. Writing that as a decimal, we get 0.96, so that's going to be our multiple, 0.96. Our initial value is 117. That was our most recent profit. So we get f of x equals 117,000 times 0.96 to the power of x. And we're going to predict the earnings in 5 years. So this x value is going to be 5. So let's plug that into our equation. We get f of 5 equals 117,000 times 0.96 to the 5th power. So going back to our calculator, 117,000 times by 0.96 to the power of 5. All right, so our profit predicted in 5 years is going to be $95,398.61. We'll just round that to the nearest dollar this time. So $95,398. Thank you for watching, and good luck on the quiz.